In this section, we're going to talk about fractions, decimals, and percents. If you recall, fractions are a way to represent parts of a whole. So we can often represent parts of the whole using fractions. Every fraction is made up of two parts, a numerator and a denominator. So for example, if you think about this pi being the whole, I can divide this pi into three parts, preferably equal parts. There you go. And each part of this pi will represent portion of the total. Okay, so this would be one part. This would be part 2 and part 3. So each slice of this pie represent 1/3 of the total. Okay, so I can say this part is 1/3 and this part is 1/3 of the total, and so is this part. Now in this section, we're interested in writing numbers as fractions and then be able to look at the relationship between decimals and percents. So going back to fractions now, fractions are either proper fractions or improper fractions. So we can actually classify fractions as proper or improper fractions. A proper fraction is the one whose numerator, the number on top, is less than the denominator. So for example, if I have AB, again, the top number is what the numerator is. The bottom number is what the denominator is. So example of proper fractions, let me just make a few here. 1/3, -2/5, 7/11. So these are all examples of proper fractions. Now improper fractions are fractions whose numerator is equal to or is greater than the denominator. So example of improper fractions would be 11/7, -4 divided by 3, and simply 3 divided by 3. Of course, 3 divided by 3 is 1. So, but nonetheless, these are examples of improper fractions. Now, often with fractions, we would like to have them in what we call the lowest terms or reduced forms. Therefore, in order to get a fraction in lowest terms, you got to make sure that we write the numerator and denominator in factored form. Okay. And then once we have them in factored form, if there are common factors, we simply cancel them and we'll keep the remaining factors. So for example, let's say I have a fraction that is 12/18. And we want to write this fraction in lowest or reduced terms. Therefore, I need to be able to write this in factored form as 6 times 2. 18 would be 9 times 2. Or you can say 6 times 2 divided by 6 times 3. Of course, we're looking for common factors here, right? So in this case, the choice of 6/2 divided by 6/3 would be a better choice. We can cross out the common factors, and the fraction in reduced terms would be simply 2/3. So that's what we call again a fraction in lowest terms. What if there are no common factors? For instance, if I have 13/15, then that fraction is already in reduced form. That means there are no common numbers, factors between the two. So that's how the fractions are reduced, by factoring them. Next, let's talk about improper fractions, the relationship with mixed numbers. Now, a mixed number is going to be a number that's made up of a whole part and a fraction part. So for example, 2 and 5/8 would be example of a mixed number. The whole number part is 2, the fractional part is 5/8. Okay. Now, these mixed numbers, you can write them as fractions. They end up being improper fractions. And the way to do this is multiply 8 by 2 in this case, and then add 5, and then divide this whole thing by 8. Therefore, this the fraction, improper fraction representation of this mixed number is going to be 21/8. Okay, all mixed number could be represented as fractions. So how do I convert an improper fraction to a mixed number now? So for instance, let's say I have something like this, 21/8, and I want to write it as a mixed number. So the way to do that, so I'm going this way. In other words, I'm going fractions, arrow, mixed numbers. We just saw mixed number to a fraction. So let's go fraction to a mixed number. An example of this one, let's say I have 2 3/4. I want to convert that into, again, a fraction, just like the one I did up here. That's a mixed number. You multiply 4 times 2, 8, plus 3 divided by 4, 4. So that would be 11/4. Again, that's converting from mixed number to fraction. So if I want to go fraction to mixed number now, we have to do long division. Okay, so let's say I have a number that's 57/4. And I want to write this fraction as a mixed number. So we have to do long division. Here's 57/4. Now let's see. You look at the tenths in the number 57. Remember, this is going to be this part of the fraction. The numerator in the long division format is going to be called a dividend. This number, the 4, is called the divisor. Okay, so we're going to look at the leftmost digit in the dividend, which is a 5. The divisor 4. And let's see, 1 times 4 is 4. Then subtract, so we're going to get 1, bring down the 7, so that's going to be 17. And now I need to, let's see, 17 divided by 4 is going to be 4. That's whole number of groups of size 4. 4 times 4 is 16. And of course, the format, the long division format, requires we subtract this from the number above. We have 1. The number 1 is here is less than 4 here. So that means we need to stop with the procedure. The process stops, and this is what we call the remainder. The 14 that's up here, this number 14 is called the quotient. Again, that would be the anatomy of a long division. Therefore, we can write 57/4 in the form of a mixed number as a quotient and a remainder over a divisor. So that would be the representation of that number. That's how you go from fractions to mixed number. You have to do long division. Okay. And let's see. Next, let's talk about multiplying fractions. Multiplying fractions. So suppose I have 2 fractions here. I have a over b, the other fraction, let's say it's c over d, and I want to multiply them. The way to multiply them is to multiply the tops and multiply the bottoms. Now remember, anytime we work with fractions, we assume the denominator is not 0. So d and b cannot be 0 in this case, because division by 0 is undefined. So that's going to be simply AC over BD. So to multiply 2 fractions, again, we multiply the numerators and then multiply the denominators. And of course, if there's a way to simplify or reduce them, we will do that. Let's look at an example of this one. The example, let's say I have 2/5, and we're going to multiply this one by, let's go 15. And then this we go 8, 15/8. So we can multiply the tops and multiply the bottoms. 2 times 15 divided by 5 by 8. Now I could multiply these. There you go. I just did 30 over 40 and simplify or reduce this fraction. This one actually works nicely because 3 times 10, that makes 30, and 4 by 10 is 40. we can cross out the common factors. The answer is going to be 3/4. Or typically what we would like to do is to write in here when we multiply tops and the bottoms, is to factor the GCF if we can and then reduce them. Okay, so in this case, 15 is product of 5 by 3 on top. Here's 5. 8 is product of 4 by 2. So we can cross out the common factors we actually before we multiply them, and we're going to get 3/4. And there you go. Either way, we get the same number. Okay. Now, let's talk about divisions. Okay. That was multiplication. Division of fractions. Let's say I have a over b divided by c over d. And the way the division works with fractions is that you actually invert, flip and multiply the second fraction times the first one. And there you have it. Okay, then so a division actually turns out into a multiplication problem. And then we can multiply the tops, multiply the bottoms. And again, for this one, it does require that b, e, and c now cannot be 0. Again, why not? Because BD0 gives us trouble here. C0 gives us problem here. Division by zeros. For that reason, we rule those numbers out. Okay, so let's see how we're going to divide fractions. So suppose, in my example here, let's say we want to divide 3/4 by 8/5. Okay, so to do 3/4 by 8/5, we're going to invert and multiply the second one. That would be 5/8. And this will give us 15/32, multiplying the tops and the bottoms. And we always make sure the answer is in lowest terms or reduced form. So there's an example there. Let's take a look at another example. In this other example, suppose I want to do divide two mixed numbers together now. Divide by 4.5, 4.5. Okay, so how are we going to do this? Well, first we need to write the mixed number as an improper fraction. So 1 2/3, you're going to multiply 3 times 1, and then add 2 to that product. So it's 3 times 1, 3 plus 2 makes 5, divided by 3, divided by 4 1/2. We're going to multiply 2 by 4, and then add 1 to the results. Okay, and that's going to make it 8. 2 by 4 is 8. 8 plus 1 is 9. That's going to be 9/2. And to do fractions, to divide fractions, we multiply by the reciprocal. 5/3 times 2/9, and this will give me 10/27. All right, and there we have this one now. So that's how we divide fractions. Now, next we're going to look at how to add and subtract fractions. So here we have adding and subtracting fractions. This was division of fractions, the one we just wrapped up here. Okay, so to add and subtract now, let's say we have two fractions. Okay, so I have something like a over b plus c over b. Notice the denominators in both cases, the denominator is b. So in other words, we have a common denominator. So we're going to choose a common denominator and simply add the numerators. Now this works with subtraction as well. So if it's subtraction, you simply subtract c from a, and that's gonna work it. And that's going to turn our addition into subtraction. Okay. So keep in mind, if the denominators are different, first we need to find the LCD, right? The least common denominator. So to see a quick example of this one, suppose I do 4/15 plus 3/15. Denominators are the same, so we get 4 plus 3/15, and that's 7/15. So nothing major here. It works out pretty simple, easily. Now another example here. Let's say we have 4/15. This time I'm going to add 5/9 to it. Now note the denominators are different this time. True? So I need to find the LCD of 15 and 9. Okay. No, we can write 9 as product of 3 by 3. And we can write 15 as product of 3 by 5. So what is the LCD? The least common multiple of these? Well, least common multiple is going to have all factors in it, common or not. And then for common factors, in this case 3. These are prime numbers, by the way. We're doing prime factorization of the number. On common prime factors, we go with the number that has the higher number. So I have, in other words, this is 3 squared, and I have 3. So there are 2 factors of 3 up here versus 1 factor. So we're going to go with the number with greater multiplicity, greater exponent, 3 squared. So in this case, the product is 9 times 5, and the LCD would be 45. Now, once we have identified the LCD of 45, we can actually build each fraction to the LCD. Plus 5/9. And to build to the LCD here, I'm going to multiply top bottom of this one by 3, multiply top bottom of 9 by 5. Note the denominators each are now 45, and we can choose a common denominator to do this. So our common denominator is going to be 45. 4 times 3, 12, plus 5 by 5 is 25. And the total is 37 over 45. And there is the answer to this addition problem. Now, if this was subtraction, you pretty much carry out the same way. Since we are reviewing for college algebra, so just go quickly through these. I'm sure this is review for almost everyone in this course. Now let's take a look at next on the relationship between decimals and fractions. So in this particular instance, I want to go from let's say decimal to a fraction. Remember, decimals are another way to represent the whole. So if I look at, for instance, 0.5, that decimal represents 1/2. So it's 1 part out of 2 parts. So that's portion of the whole. So let's take a look at how we convert decimals to fractions. So all we got to do when we convert decimals to fractions is we simply read the decimal using the correct place value. Okay, and then we write it in fractional form, just as it reads. Okay, so for example, let's say I have the number is 0.056. Okay, this number in place value, the first digit is in the the tenths, right? Tenths. The second digit in place value represents hundredths, and then the third digit represents the thousandths. There you have it. So all I have to do is read this number. This number is 56 thousandths, correct? So I'm just going to write it as 56 over 1,000. And that's it. It's 56 thousandths. And that's what we want to do. Again, just read it, 56 thousandths. And there we have it. Now, of course, you can reduce the fraction, right, in the lowest term. I just want to show how to go from decimal to fractions. If the number, for example, is, let's say another example, suppose it's 4.31. Okay, so we want to write this number now in fraction. How do we do this? That's the decimal, not multiplication. So for this one, we go 4 and 31 hundredths. So we can actually write it as a mixed number and then go from mixed number to a fraction. See, remember how this went? 100 times 4 is 400 plus 31 over 100. So this number is 431 hundredths as a fraction. Okay, so it is fairly easy to go from decimal to fractions. You just read the number. That's all you gotta do. Then you can add, subtract fractions. Usually we use calculators to do this. Their multiplication and division. We're allowed to use calculator in this course, so we're going to do that. Now, the other thing we want to do here, let's say we want to go fractions to decimal now. How do I go from fractions to decimals? To go from fractions to decimals, we have to do long division. So let's see, for instance, let's say my example, I want to do 2/3. I want to convert 2/3 into a decimal. So the numerator is 2. That's going to be the dividend. The denominator 3 becomes the divisor. Now, because 2 is less than 3, we're going to put a decimal, and we're going to actually insert some zeros, just a few in front of it. This can go on indefinitely, but we just want a few of them. We're going to line up the decimal in the quotient with the decimal in the dividend. And again, because 2 is less than 3, then there are no whole numbers that we can start this with. Now, what are we going to do? We actually use another digit next to 2. So think about 20 now. And then we divide 20 by 3. The result is, so 7 times 3 is 21. That's too big. So we're going to go 6. Okay. And then 6 times 3 is going to be 18. You don't need to carry the decimal any further. We know it's there. And then we subtract. So subtract 18 from 20, we get 2. And then because 2 again is less than 3 in this new remainder, we're going to bring down another 0. And do it again. Next time, again, 6 times 3, 18. 2. Bring down another 0. And so on and so forth. So it looks like this process is not going to stop, right? It's going to go indefinitely with a never-ending trails of 2. And just write it one more time. And you can kind of see that this goes on and on. Therefore, as a decimal, this is going to be 0.666 and so on. And of course, we can use the bar notation, right? We can put a bar. Usually when we have repeated block of digits, we put the bar. The bar is written over the repeating digit or digits. And of course, we can round this, right? We can round it if you want to round 0.66666. Let's say we want to round it to the nearest tenths, hundredths, thousandths, to the nearest thousandths. You look at the digit immediately to the right of this. If this digit is going to be greater than or equal to 5, we round up to the next higher digit. So this is going to be 0.66. That's going to be rounded up to a 7. And you turn all these other digits into 0, which we don't write them. Okay, so I'm just going to erase them. Therefore, rounded to the nearest thousandths, the number is 0.667. As far as rounding goes, let's say I have 0.123455. And I want to round to the nearest thousandths here. You look at the digit immediately to the right. This time, if the number is, or the digit here is less than 5, you always round down. The idea of rounding is which number is this number closest to with respect to the place value. Okay, so that's why you round up or down. This number is closer to 0.123 than it is to 0.124. And that is why we round up. The number we see up here, the number 0.6666 and so on, endless trails of sixes. This number is closer to 0.667 than it is to 0.666. So we round it up. Okay. And there we have conversion of fractions to decimals. Now, having talked about fractions and decimals, let's talk about percents. Okay, we can write percents as decimal and decimal as percents. The word percent, by the way, means per 100. Okay, think about our currencies. We have dollars and cents. Every 100 cents is $1 for us. So percent here, think of it as per 100. Okay. Now 1% means 1 per 100 or 1/100ths. Okay. Therefore, let me just put the word percent means per 100. That's the literal meaning of it. Now the percent symbol is the symbol we use. 1% represents 1 over 100, which as a decimal is 0.01. If you look at, for example, 5%, that's 5 over 100 or 0.05 in place value. Remember, you just read the fraction 5/100ths, and that helps us write it as a decimal. If something is 100%, as a decimal, that'd just be 1, wouldn't it? Now, so how do we convert percent to decimals? So let's take a look at, for example, we're going to go percent to decimals. To go from percent to decimal, let's say I have 74%. All you got to do is read the number 74 per 100 and then write it. This is 74/100ths. So the answer is 0.74. So I can convert. First you convert to a fraction, then you convert to a decimal. All right, and that's what that is. So to convert again from a percent to a decimal, the percent to decimal, we can do it this way using fractions. Now let's say we need to do this. Suppose we want to convert now from decimal to percent. Decimal to percent. Oh, and also before I leave this one, there's another way to do conversion from percent to decimal. If you look at the decimal in number 74, this is where the decimal is, right, in our place value. So another way we can do this is simply with 74%, you can move the decimal to the left 2 places. So this is actually going to be 0.074. That's just moving the decimal, bypassing the middleman. Okay, so we don't have to necessarily go through fractions. We could. Doesn't take long, doesn't take much. But that's another way we can do this. So you can think in terms of moving the decimal to the left. Now, when you do decimal to the left, it's like you're dividing the number by 100, actually. That's what we're doing. The movement. Each time you move to the left, you're dividing by a factor of 10. Move to the left 2 places. That's like dividing by 100. Dividing by 100. That's what that is. Okay, and of course you got to remember to drop the percent. If you put the percent there, now that's inaccurate, incorrect. All right, and let's say, how do we go from decimal to percent? To go from decimal to percent, like 0.74, you do just the opposite. This time the movement is to the right. That's going to be 74. Notice the number 74 now is 100 times bigger, isn't it? So it's really like multiplying by 100. So to multiply by 100 is to divide by 100, right? To keep the same number. I multiply by 100, I need to divide by 100. And remember, the percent symbol means 1 over 100. So that would replace the division by 100. You got to make sure you put the percent symbol in front of this. Okay, so that's how you convert between them. And how do we write fractions now as percents? Let's take a look at something like that. I'm thinking about, for instance, I want to convert 2/5 to a percent. Okay, so to do this, we can actually multiply by 100%. 2 times 5 by 100%. Remember, the percent symbol means 1 over 100. So what I've done here is really haven't changed the number. Okay, that's like multiplying by 1 in the form of 100%. And then I can do this. I can go 2 times 100 divided by 5 times 1. And then I can simplify 2 times 5 times 20 divided by 5. And of course, got to remember the percent or the whole thing is incorrect. Okay, that's going to be 40%. So that's one way to do it. Another way to convert to a percent is you can build the fraction up to 100. Let's check this out. If I have 2/5, I'm going to multiply top bottom by 20. Now I get 40 over 100, correct? And then remember, the percent symbol represents 1 over 100. So at this point, I can just go 40%. That would also work. Now this works nicely if you can build the denominator to fraction. To 100. So 5 times 20 gives me 100. What if that denominator wasn't something that I can build to 100? So for example, let's say the fraction is 1/6. And I want to write this as a percent. See, this time, what am I going to multiply so this becomes 100? In fact, 100 is not divisible by 6, so this isn't going to work nicely. So I'm going to stay with my earlier recommendation. We do times 100% and write this as 1 times 100 divided by 6. And maintain the percent symbol, and that's 1 times 2 times 50 divided by 6. Okay, and of course 6 we can write it as 2 by 3. Maintain the percent symbol. Cross out the common factors, that is. So this is 50 divided by 3%. Now I can do 50 divided by 3. 50 divided by 3, well, 1 times 3 is 3. Subtract. We get 2, bring the 0, 3 times 16, 3 times 6 is 18, subtract, we get 2. And of course, this thing is going to repeat as 20, 20, 20. So at this point, I'm going to stop. The answer is going to be 16 2/3. So 50 divided by 3 is going to be 16 2/3 of a percent. Or you can go 16.6666 and so on. But notice I have the exact percent here, by the way. And there you have it. So hopefully what I have here, you can follow the work that I have done here. Next, I'm going to do some examples. Let me quickly browse through and... yeah, we covered pretty much the review material that we wanted to do with fractions, percents, and decimals. So let's take a look at some other variable examples now. Okay, so let me do some of these examples. So in my example here, let's say the number is 15/18, and we want to write this as a fraction in lowest terms. So we want to reduce this one. Remember, to reduce this, we need to get common factors, the GCF. So 15, I can think of 15 as product of 5 by 3. 18 would be 6 by 3. Those are the common factors, correct? And then we can always cross out the commons. And then what we end up with is actually 5/6. And there you have it. The answer is 5/6. Now let's do another example. Suppose I want to do 120 divided by 144. So we need to find common factors here. If you can find the GCF, we can do this in as few steps as possible. If you can't recognize the GCF, just break it into common factors. So for example, let's say I know that 12 times 12 is 144. And 120 would be 12 times 10. Now, this is not the GCF, but it's going to do, right, as long as I have a common factor. The 12 crosses out, and then I'm left with 10 over 12. Because they're both even, then I know that this is divisible by 2, both 10 and 12 are. So that would be 2 times 5, 2 by 6. The 2's cross out, so the reduced form is 5/6. Okay, now, had I recognized from the beginning, which is kind of harder to do with the larger numbers. So this works out fine. But let's say the GCF, somehow I was able to know that the GCF is going to be 24. How do I know that? Because notice how I canceled 2 and 12, so that must have been common, right? I'm guessing GCF is 24. So in other words, 120 over 144 would be divisible. Both of these will be divisible by 24. 24 times 5 and 24 times 6. And now I can cross them out. The advantage of identifying GCF is you can reduce these in one step. Okay, but again, you were able to do it in 2 steps, no biggie. Let's take a look at another example. In this next example, let's say I want to write this improper fraction as a mixed number. I'm given an improper fraction. We want to write it as a mixed number. Remember, we have to do long division. 77 divided by 12. Well, I know 6 times 12 is 72. Right, and subtract, that's 5 remainder. So the answer is going to be a quotient, a remainder over a divisor. So it's going to be 6 and 5/12. That's going to be the mixed number. Okay. Let's do another one. How about this time you want to write the mixed number as an improper fraction? Just go the other way. So this time, in this next example, suppose I have 12 and 2/3. And I want to write this again as an improper fraction. So we're going to do 12 times 3, multiply these two, add the numerator, divided by the denominator. And there we have that one. So that's going to be 36 and 2, that's 38/3. That's going to be the improper. Notice the numerator exceeds the denominator. So sometimes we care about improper fractions, other times they don't. They want us to write it as mixed numbers. So we can go back and forth between the two of them. Next example, let's take a look at how we would now multiply or divide fractions. So for this one, let's say I have 12 divided by, make it smaller. Let's go, I have 2/15 times 3/8. So how are we going to do this? Remember, we're going to multiply tops and the bottoms. 2 by 3, 15 by 8. Now, you could do 2 times 3, 6, 15 times 8, 120, and reduce it that way. Or the recommendation is to reduce them before we multiply them. There. So that's going to be 1 over 20. 4 times 5 is 20. And there you have it. You get the exact same result if you did 2 times 3, 6 divided by 120. Let's do a division. And so in our division, suppose I have 5/4, and I'm dividing this one by now 3/8. So what I can do is 5/4 times, invert and multiply, we get 8/3, right? And there we have, we can cross those, multiply the tops, multiply the bottoms. Now when you multiply two numbers, by the way, be careful please. I put this what we call a center dot. Center dot. That represents the multiplication. Because look at this, 5 center dot 2. That's clearly product. If you move that dot lower, now this becomes a decimal point. So you got to be really careful when you multiply using dots and decimals. And that's why I emphasize and make it boldface or something to emphasize that these are not decimals, they're multiplication symbols. All right, and then we're good to go here. That's going to be 10/3, right, as an improper fraction, or 3 1/3 as a mixed number. Let's try another one. What if, let's do an addition or subtraction. How's that? So suppose the easy example. Suppose I want to do 7/15 plus 4/15. So because the denominators are common, we can choose the common denominator and simply add the numerators. That's going to make it 11/15. And that's it. That's all we got to do. Cannot remove any common factors in this one. Let's do one where we don't have a common denominator, 3/8 plus 5/6. Again, the LCD, the least common multiple of these two. The prime factorization of 6 is 2 by 3. Prime factorization of 8 is 2 cubed, 2 by 2 by 2. For the LCD, we're going to write factors that are common or not. So 2 and 3 we're going to write. 2 is common, clearly, right? That's the common factor. The choice on common factor is to choose the one with higher exponent. This is going to be 2 cubed. 2 cubed, 8 times 3, 24. So 24, notice that's not the GCF. The GCF would have been 2. This is the least common multiple. Now this is called least in the sense that 24 is the least, meaning the smallest. Is the smallest number that is divisible by both 6 and 8. As you can see, 24 is product of 6 times 4. 24 is product of 3 by 8. However, there are other numbers. For example, 48 can also be written as product of what? 48, 6 times 8. And 48 is going to be 8. Oh, yeah, I got it. It's going to be 8 by 6, but that's not going to help. I don't want that one. Let's go, I don't know, 240. 240 is divisible by 6, right? 6 times 40. And 240 is divisible by 8. 8 times 30. So there are other common multiples of 6 and 8. But the one that we want is the least, the smallest. 24 is the smallest. This number can get extremely large, very large. We don't want the largest one, we want the smallest. Now, once we identify 24, of course, we need to rewrite the denominator of each of those fractions using 24. So I'm going to go 6 by 4, 8 by 3. And got to do the same thing. Whatever you do to a fraction, you do to the top and the bottom as well. And there we have these. So we have 9 divided by 24 plus 20 over 24, which combines to 29/24. Okay, so there we have this one. That would be 7/15 plus, I'm sorry, that would be, this is a different example, right? That's 3/8 plus 5/6. All right, so that would be the answer again, 29/24, which of course we can write it as, you do long division, we get what, 1 and 5/24 as a mixed number. Both of those are acceptable. Let's do a subtraction, the last one, and we'll be done with this lecture. lecture 1. So I have, let's say I have 7/12, and I'm subtracting 1/9 from it. So we need to get LCD, correct, on this one. The LCD would be, let's see, let's go through our prime factorization. 9 is 3 squared. 12 is product of 3 by 4, which is 2 squared. The LCD is going to be prime factors, common or not, we list them. 2 squared, common prime factor 3, the higher exponent 2. That's going to be 4 times 9. Wow, 36. 36 is the least, the smallest number that is divisible by both of these. 36. So now I need to do the building part, correct? I'm going to build these. Times 3, that gives me 36. And 9 times 4 is 36. True? So once we have the common denominators, let's choose the common. 7 times 3, 21, minus 4, that's going to be 17, 36. So there we have the answer to each one of these. And hopefully that you find this, again, easy to follow. Let's see, I want to make sure I covered everything. What if, well, let's do a few more different kind of exercises here. I see. Let's try to write now a fraction as a decimal. In this example, we want to convert, for instance, 9/4 to decimal. That's what we want to do. So to convert to decimal, remember, we have to do long division. So there is 9. I put 9 decimals 0. Make sure you put decimal, otherwise it's 90. So 9 divided by 4, 2. That's 8. And the remainder is 1. Okay, so what are we going to do now? We're going to actually bring down the 0. Let me put a few zeros here. Bring down this first 0. Now 10 divided by 4. Oh, and this is a decimal in the answer, in the quotient. See, I line up the decimals. So 10 divided by 4, that's going to be 2. 2 times 4 is 8. Subtract. And we get 2. Bring down another 0 down here. 20 again divided by 4. This time is a 5. 5 times 4, 20. Perfect. No remainder. If there's no remainder, that means the decimal representation, we have a terminating decimal. Means the digits are not going to go on indefinitely forever. The answer is going to be 2 and 2 1/4. Now, ordinarily, you do this on a calculator, right? You divide 9 by 4, and there it is. Just want to show you how we can do it without a calculator. Let's look at another example here. This example, suppose example is 2.4%. This time we want to go from percent to decimal. Let's say we want to write each percent as decimal. So how are we going to do this one? Remember, the easy way is to move the decimal point. Because we drop in the 100, it's like to divide by 100. So here's a new decimal, and you put the 0 there. The answer is going to be 0.024 as a decimal. Okay, 2.4% is 0.024. What if I go from decimal to percent? Let's do that. We want to go, again, decimal to percent. To go from decimal to percent, I want to make sure I get that C there. Decimal to a percent. What do? We move, again, the decimal, right? From decimal to a percent. So suppose my number is 1.28. Okay, so we're going to move the decimal to the right 2 places. That's going to be 128. Notice the number is 100 times bigger than what it used to be. Put a percent because percent represents 1/100. So that way we can go back to the original number. What if I want to go from percent to fraction? Let's say another example. Suppose I have 15%. To go from percent to a fraction, you just replace a percent with 100, and there you have it. So that's going to be 15 hundredths. And remember, all fractions we want them reduced. So 15, that would be a product of 5 by 3 divided by 5 times 20. The 5's come out, so the answer is 3/20 in reduced form. Okay, and the last one for this lecture. Suppose I want to write now, let's see, let's do a fraction as a percent. How's that? 7/50. Remember, if the denominator, you can build it to 100, fine, but let's do it as if we don't have that. So we're going to multiply by 100%. That would be 700/50, which reduces to 70/5. Now 70 divided by 5, we're going to do long division. 1 times 5, 5, subtract. 20 divided by 5 is 4, no remainder. So it's going to be 14%. That's what that is. Okay, 14%. That's the percent representation of that fraction, the 14%. Which you could have done very easily. In this case, multiply top bottom by 2, and you get 14/100, which is 14%. But again, the reason I carry the longer format, this, because not all fractions can be built to 100 exactly. So for instance, last exercise or example here for us, suppose I have 2 11ths. See, now 100 is not divisible by 11, so I cannot build this to 100 using whole numbers. So what do we do? Then you go 100%, and then you go 200 divided by 11 now. Here's decimal in 200. So 20, the leftmost 2 digits are 20. 20 by 11, that's 1. Subtract, we get 90. 8 times 11 is 88. Subtract, we get 2. Bring down the 0. Yeah, because this thing is just going to go on and on and on. I can see. But let's try it anyway. 20, so this is going to be 1. Subtract, we get 9. Now you have 90 divided. You see how that goes on like that? So let's try the exact percent. The exact percent is going to be 18, right? And the remainder, when I did 18, let me go back here, 200 divided by 11, 1. Subtract, we got 9. I brought the 0 down. Then we went 8 times 11 is 88. The remainder was 2, right? So this fraction is going to be 18 and 2/11%. You see how we can actually write the exact fractional form of that. 18 and 2/11. If you want to again approximate this, if you want to go with decimals, you could. You can continue on this path, and you should get something like 18, 18, 18, like that. Endless pairs of 18, which we can use the bar notation. And don't forget, by the way, the percent. I just did, so I put it back on there. And there you have it. Complete lecture for basic stuff, pre-algebra level. But again, that's what we're doing. We're just reviewing some things here. So we're done with this lecture, and this, we call it lecture 1. Thank you for watching.